So this is an interesting way we're discussing the different rates of change. So say you go to a bank and they're compounding your interest quarterly. So you have every ability to find the quarterly percent rate of change. That means T is a quarter, and subtracting 1, doing all that wonderful stuff, you get 2.3% is the quarterly percent rate of change. Now, we know a quarter is a quarter of a year. So if we're going to determine the annual percent rate of change, if you think about this linearly, this is not linear, this is an exponential. But if you think about it linearly, if I had multiplied that by 4, that would give me approximately 9.2%. Now, this is not a linear equation, so we can't do that. But you get the idea. We're not changing how we're compounding. We just want to know, okay, in a year, how much am I going to have, kind of thing. So that's the idea that this is behind this. The way we do it is really awkward. So just so you know, we're in it. So we know that 1.023 is the base here. And we know T is quarters. So if I put 8 in there, 8 would be 2 years, right? If T equals 8, then 8 would be 2 years. How did I figure that out? Well, I just divided it by 4. And that's the idea behind doing this. If I divide this by 4, then I'm going to find the yearly. However, I just can't take a formula and say, okay, I'm just going to divide that by 4 now. That's not allowed. So what we have to do is we have to use the fact that 4 over 4 is 1. So basically what's happening is I'm doing this to the equation. And I'm taking this 4 right here and I'm putting it inside. And I'm leaving this 4 outside because that's going to tell me the number of years. If I plug 8 in for quarters, then 4 over T would be my years. So I know that this number right here is going to be years. So now that I know that's a year, then I know what I'm going to find inside here is going to be my annual percent rate of change. It's a little weird. That's why I'm not, crazy about it. But it's just, and it's actually quite interesting. It's just a little, interesting to get used to, let's say. So if I do this math, this is what I get. Something like this. Okay, so this to the T over 4 years. My stylus isn't working very well. Okay, so I get this is my base now. So this is going to tell me my annual percent rate of change. Okay, so I'm not changing the formula at all because it's just 4 over 4 here. That's still a 1. What I'm doing now is saying, okay, if I want this to be years, this is going to be my annual percent rate of change. Because it's exponential, I can't just multiply it by 4 and get that. I have to do the exponential piece. So when I do this, it winds up being, 9.5%? Because we know all the subtracting 1 and multiplying by 100 and 9.5%. Pretty interesting, right? Okay, so then determine the new formula with an annual percent rate of change. So all I'm saying is rewrite this sucker. And when I rewrite the sucker, A of T is going to be, the T is quarters. Okay, so that means I have to leave the T over 4 in the problem. So the formula is 1.095222948. This is what my calculator told me. Okay, now if you round, things aren't going to work out as perfectly, but it's still going to be pretty darn close. Okay, and then if I want the formula to be in years, that means that this piece right here isn't T over 4 anymore. I'm just going to put a number for years. So it's going to be the same exact formula. Okay, to the years. Okay, so now if I use both of these formulas, okay, you saw that. If I use both of these formulas and I say, okay, compare the results of the original formula. So that's the one that we have at the beginning that you can't see right now. So that's A of T equals 4,500, 1.023, okay, to the T power. That's the original. If I compare that one, where the number of quarters is 12, and I use one of these two, either one, they're both the same thing, so I'm just going to use this one because this one uses quarters. All right, so if I do this as A of 12, and that means that I'm plugging 12 in here, what I'm going to get is 5,911, 80, whatever, etc. If, and I put it in this formula, so A of 12 equals 4,500, 1.095222, whatever, to the 12 over 4. Sorry, my stylus, again, is not the best one I've ever used. We get almost exactly the same formula. So really what's happening here is these two formulas are the exact same thing. Okay, we're just rewriting it so one of them shows my annual and one of them shows my quarterly. It's weird, but it has use in finances and things like that. So let's try another one. Okay, so the following shows a yearly trend in aardvark population. What percent are the aardvarks increasing? So hopefully you realize we get it from here, so that's 10%. We don't have to go deep into that because you are aware of that. By what percent are the aardvarks increasing every month? So this is a year. Okay, this formula right here that I'm showing is showing yearly, so T is years. Now they want to know, okay, so how's it changing every month? How many aardvarks are we going to gain every month? Okay, and this works with losing also, and you take it from there. So what I do is I think about it, okay, so if I think about maybe, so this every month, so basically what I'm thinking about, if it's 10% every month, every year, what is it every month? Well, again, if it was linear, I would just divide it by 12, and it would be a little less than 1, correct? However, if I think about, since it's exponential here, I need to change this and figure it out exponentially. So if I just think about this logically, I have to think about, okay, so if I put 3 years in this formula here, how many months is that going to be? Well, 3 years is equal to 36 months. How did I figure that out? Well, I multiplied my number of years by 12. So that's what I have to do in the formula. So it's 1.10, and this new formula has to be 12t. But I can't just do that. You can't just put a 12 on something. You have to then, on the inside, make it 1 over 12. Do the math here. 1.00797,414. Okay, and that's approximately 7.97%. No. Yeah. Go Miss Barris. Okay, that's, yeah, I had it written down right, I just didn't write it right. So it's 0.79% or 0.8%, which is less than 1%, which is approximately what I would get if I divided 10 by 12. Okay, so if you can grasp this, I moved it over 2 decimal places, and that's why it's 0.8% or 0.80%, excuse me, and that's why it's, anywho, I'm really good at this. Okay, formula using years, so it's the same basic problem. If I want to create a formula using years, A of t, so it's 3652. So I'm using years, 0.00797 to the 12t. And then the formula using months, same formula using months, would be 3652, 1.00797, and this would now be an M instead of a 12t. So this 12t is reminiscent of months. of years, excuse me. The t is years, so I multiply it by 12, and it's going to be, yeah, I'm doing well here. Anyway, so if I use these two formulas, compare the results of the original formula with one of the new formulas. So my original formula, as a reminder, is a of t. Okay, I'm using my finger now, so that's why it's all weird. Okay, 3652, 1.10 squared. That answer is, because I wanted to do it with 2 years, this is a 2, 4418.92. Now, if I do, let's do this one, using years again. A of 2 is equal to 3652, 1.00797, etc. to the 12 times 2. It's 4418.48. Now, I rounded here. So if you didn't round, I would have gotten a lot closer. So this difference here is because of my rounding. It would have been a lot closer, but you have to realize that if I did put the original in, it would have been 4418.919955, which is almost exactly 0.92. So it's always very close. The less you round, the closer your answer will be. But what you have to realize is that this original formula and these formulas that we use with months and years and things like that are the same formula. We're just getting an idea of what the actual annual percent rate of change or monthly or quarterly given 1%. So we're just dividing it up between each segment of time. All right. See you tomorrow.